In 1964, something strange was detected coming from a star in the constellation Cygnus. At first, it looked like just another ordinary star. But as scientists listened to its radio waves, they realized there was more going on. The source of these waves was orbiting something invisible. It was a black hole. This discovery forever changed our view of the universe. So how did those scientists manage to find this invisible monster? And what do we know about it today? This is the first black hole ever discovered. Black holes are mind-bending objects. They warp space and time in ways we're only beginning to understand. These warped regions of space are known as curved space. And this warping happens because black holes have gravity. Their gravity messes with light, bending it and distorting it. That means once an object falls into a black hole, not even light can escape its grasp. Once it's gone for good. Because of this, the only way to spot one is by observing the effects it has on other objects. And this is exactly how the first black hole was spotted. But let's go back to the start. In the early 1960s, astronomers were searching for quasars. A quasar is an extremely bright object that is powered by a supermassive black hole at its center. We think of quasars as being the brightest objects in the universe. But in the early days, scientists didn't know what they were looking for. What they did know is that many of these mysterious bright objects were located in the constellation Cygnus. So they decided to focus their search here using a radio telescope in West Virginia. Arno Penzias and Robert Wilson began scanning the skies. They had no idea what they would find, but what they heard changed science forever. Coming from the direction of the constellation, they heard a strange noise. They tried to pinpoint where it was coming from and realized it was coming from a single star. They named it Cygnus X-1. At first, this blip on the radar seemed like nothing special. But over the next few weeks, the pair noticed something weird. It wasn't a star, at least not an ordinary one. Whatever was out there was orbiting something invisible, a massive object that couldn't be seen but whose presence was felt through its gravitational pull. This invisible object was most likely a black hole. To understand why, let's take a look at a regular star. Stars shine by converting hydrogen into helium in their cores. This process releases tremendous amounts of energy, creating the light and heat that makes stars shine. As stars shine, they also spin. Most stars rotate on their axes, and this rotation causes them to bulge at the equator. Our sun is not a particularly fast rotator, though if it were, its gravity might become so warped that nothing, not even light, could escape its grasp. And that's what's happening in Cygnus X-1. Something massive is causing a star to spin incredibly fast. The star is being pulled so tightly that it has become distorted. But what could cause such a thing? The answer was staring them in the face. Well, not really, because it's invisible. But Penzias and Wilson had just discovered the first black hole ever. They didn't know it at the time, though. To prove that this invisible object was actually a black hole, they needed evidence of its existence. The first piece of evidence came when they analyzed the sound coming from the star. When studying stars, scientists listen to sounds called pulsars. A pulsar is basically a star's heartbeat. It's the rhythm created by its brightness as it spins. And by studying these pulsars, scientists can learn a lot about a star. For example, by measuring how fast the pulsar is, they can work out how fast the star is spinning. After analyzing the sound of Cygnus X-1, Penzias and Wilson realized that the star was spinning around 6 times per second. This was far too fast for any normal star. Something massive and invisible was warping the star and causing it to rotate at incredible speed. This meant that whatever was out there had to have a mass around 30 times that of the sun. And if it had a mass that big but couldn't be seen, it could only be one thing, a black hole. With this new understanding of the unseen object, scientists could calculate its gravity. If they knew its gravity, they could then work out its mass. And by knowing its mass, they could tell whether or not it was a black hole. Objects in space are all governed by Einstein's equations. His famous equation, E equals mc squared, shows the equivalence between mass and energy. To calculate the mass of a black hole, all you need to know is how much energy it's emitting. So Penzias and Wilson analyzed the brightness of the star and used Einstein's equations to work out the amount of energy being emitted. They discovered that the invisible object was emitting around 10 to the power of 38 ergs per second. Using E equals mc squared, they then converted this energy into mass. And it became clear that the object was around 20 times more massive than the Sun. This made it a black hole. Its gravity would be so strong that nothing, not even light, could escape its grasp. Once they knew they were dealing with a black hole, they could study the object properly. With more observations, they realized that the black hole was orbiting a star at least 30 times larger than our Sun. Because of this, it was giving off more energy than a typical star. The pair watched as material from the star spiraled toward the black hole. Some of this material formed a disk around the black hole, and this disk glowed brightly, giving off huge amounts of energy. Today, we call this a quasar. The black hole at the center of the galaxy is probably what caused the star to begin spinning rapidly. It created such a strong gravitational force that it pulled matter away from the star. This material then formed an accretion disk around the black hole. And this accretion disk is what powered the quasar. Quasars are among the brightest objects in the universe. They are often thousands of times brighter than our galaxies. Quasars are now thought to play a key role in the evolution of galaxies. These bright centers of energy may help to regulate star formation throughout the galaxy. But quasars can also be dangerous. If a star gets too close, its gravity can rip it apart. In some cases, this can form a cloud of gas and dust around the black hole. This cloud is known as a torrent. Tori are thought to play a key role in the life cycle of a quasar. They may help to protect the black hole from being destroyed by the very matter that it consumes. These days, scientists have a pretty good understanding of how quasars work. They know that they are powered by supermassive black holes at the center of galaxies. They also know that they play a key role in the evolution of galaxies. However, they still don't know how quasars turn off. We think that when a galaxy runs out of gas, the star formation will slow down and the quasar will fade away. But we don't really know. Since Penzias and Wilson discovered the first black hole, scientists have found many more. We now know that black holes are among the most mysterious objects in the universe. They warp space and time in ways that we're only beginning to understand. Studying black holes helps us to learn more about the fundamental nature of reality. It also helps us to better understand our place in the universe. So, what is a black hole? Simply put, a black hole is a region of space with gravity so strong that nothing, not even light, can escape its grasp. Black holes are created when a star collapses in on itself. They are incredibly dense and have a powerful gravitational pull. Anything that gets too close to a black hole is pulled in and destroyed. There are 4 known types of black holes. The smallest ones are called stellar black holes. Stellar black holes are created when a star collapses in on itself. They typically have a mass of a few times that of the Sun. The next type of black hole is a little more complicated. These are intermediate black holes. Intermediate black holes are thought to form when 2 or more stellar black holes collide. They typically have a mass of a few hundred to a few thousand times that of the Sun. The third type of black hole is a supermassive black hole. Supermassive black holes are the largest type of black hole. They typically have a mass of millions or even billions of times that of the Sun. And finally, there are ultramassive black holes. Ultramassive black holes are the rarest and most massive type of black hole. They typically have a mass of trillions of times that of the Sun. Black holes are one of the most mysterious objects in the universe. They warp space and time in ways that we're only beginning to understand. Studying black holes helps us to learn more about the fundamental nature of reality. It also helps us to better understand our place in the universe. If you want to learn more about the universe, check out the video on your screen.